Today we shall start a series of videos on circle and its properties. This will cover the study of circles from grade 5 to grade 9. In part 1 of these videos, we shall try to define what a circle is and its related terms. These keywords students must know thoroughly and remember to understand the properties of circles clearly. Then solving problems on circles will be easier for them in next step. We shall learn all these topics with paper folding and coloring activities. The students should be advised to bring paper cutouts of circles from white sheet of paper of same radii ranging from 4 to 5 centimeter, and 7 to 8 paper cutouts should be enough for each day activity. At the very outset, let us define what a circle is. A circle is a simple closed two-dimensional figure made of set of points on a plane. Each of these points is equidistant from a fixed point on the same plane. This fixed point is called the center of the circle. A circle divides the plane on which it lies into three portions. One is interior of the circle, that is within the boundary of the circle. Second is the exterior of the circle, that is outside the boundary of the circle. And thirdly, the circle itself, which is the circumference of the circle. The circle with its interior is called the circular region. We shall now describe the different parts of the circle. The most important part of the circle is the radius. What is radius? Radius is the line segment joining the center of the circle with any point on the circle itself. That is the circumference. So this is one radius. Any line segment joining the center of the circle with any point on the circumference makes a radius. So as we can see, this point is equidistant from all the points, and if we start joining the center of the circle with these points, we shall get infinite number of radii, and they are all equal in length. Now, why do we call radius as the most important part of the circle? Because if there are some circles with same radii, we know that the circles will exactly match with each other in size. That means they will be congruent. From radius, we can calculate the diameter of the circle, the circumference of the circle, and the area of the circle. That means the surface covered by a circle. Next is diameter. Diameter is any line that passes through the center of the circle and its endpoint lies on the circle itself, that is on the circumference. So if we draw a line through the center to another point on the circle itself, then it gives rise to a diameter. So here AB is the diameter. And we have learnt just now that radii are infinite in number. And you can well understand, if the radii are infinite in number, the diameters will also be infinite in number. So this is another diameter, just for example, but it goes on like this, joining any 2 points on the circle itself that goes through the center is diameter. All the diameters are the line of symmetry for a circle. For example, if we take this circle and we just fold it through the center, we shall get a diameter. And along the diameter, if we fold, we get exactly two mirror images of two parts of the circle. And this is of course true for all the diameters. These are called the line of symmetry. Diameters are the lines of symmetry for a circle, and obviously the lines of symmetry are also infinite as the diameters are infinite in number. Another unique property diameter has, that is its relation with the circumference. If we take circumference as C and diameter as D, then C by D for any circle has an unique relation, and it is always a constant that is denoted as pi. Be it a small circle like this or the largest circle that we can imagine, the circumference divided by the diameter will be a constant, that is pi. The value of pi is approximately 3.14 ... or also 22/7 approximately. These are all approximate values. Pi is an irrational number, that means non-terminating, non-recurring decimal number. So from here what do we get? We can see from here that diameter is the sum of two radii. This is one radius. If we take center as O, AO is one radius, BO is another radius. If this diameter is MN, then MO is one radius and ON is another radius. So diameter is the sum of two radii. So D is equal to 2R. If we take radius as smaller, then we can replace D by 2R, because diameter is the sum of two radii. So C by 2R is equal to pi. So circumference is for any circle. So C is for circumference. Circumference for any circle is equal to 2 pi r. There are two more keywords that follow diameter. These are arc and chord. What is an arc? If we take any 2 point on the circle, on the circumference of the circle, then we are dividing the circle into two parts. Let us call it P and Q. We put an R here. PQ is the minor arc. What is an arc? Arc is part of a circle. So PQ is the minor arc and PRQ is the major arc. So how do we denote minor arc? PQ is the minor arc. The major arc is from P along this line and ends at the same end point, P and Q. So major arc we denote as P R Q. Now if P and Q lies on the endpoints of diameter, then both the arcs become equal. A and B are the endpoints of the arc. Then we are getting one arc ARB and another arc, let us put an S, and ASB is another arc. Both these arcs are same. In that case, we don't call them major and minor arc because both these arcs are of same length. So after arc comes chord. Chord is any line segment joining any 2 points on the circle. So if we join P and Q, this is a chord. If we join any 2 points, this is a chord. This is a chord. As we can see, chords are also infinite in number. We can draw anywhere chords. We can later see with activities, with paper cutouts, that chords are also infinite in number. As we can see here, the line segment AB, which is the diameter, is also a chord. Same with M and, because these are the A and B, M and N are the points on the circle. So, line segment joining any two points is a chord. So, diameter is also a chord, and diameter is the longest chord. We shall go into greater details on chords and its properties in part 2 of this video, because it is extremely important to understand chord to solve geometric problems on circles. Before ending this session, we shall describe the segments and sectors of a circle with paper cutouts of circle. What is a segment in a circle? If we fold one end of the circle to get a chord, this is a chord. Diameter is also a chord, but now we are considering this chord. This is a chord because it is joining two endpoints on the circle, one here and another here. So, this is a chord. If this is a chord, the area between this chord and the minor arc is called minor segment. We may color this with red. This is the minor segment. So, minor segment is the area between the chord and the minor arc. If the children perform this activity, they will remember the definition by doing it. This is the minor segment between the chord and the minor arc. And what about this part? Between the chord and the major arc, this is called the major segment. Let us color it. So, between the major segment and the minor segment, the chord is the partition. This blue part is the major segment. So, major segment is between the chord and the major arc. Student will find no difficulty in remembering that once they do the activity themselves. You can just draw a line along the chord. That will show the distinct division between the minor segment and the major segment. So, the red part is minor segment and the blue part is the major segment. There is another interesting point in a circle, that if the chord is the diameter, what will happen then? Let us again fold a line out through the center. So, this is the diameter. If this is the diameter, what about the segment then? Diameter is also a chord. So, between the diameter and this arc, and between the same diameter and this arc, these two areas are two segments. And here there is no major or minor segment because both are equal. So, when the diameter is the chord, both the segments are equal. This is all about segment. For sectors, we use another paper circle and fold the circle to find two radii. So, joining the center with any point on the circumference, one radius is this one and another is joining the center of the circle with another point on the circumference. So, what we are getting? We are getting a triangular part bounded by arc on one side and two radii joining the end points of the arc with the center. From this activity, Children can easily remember the definition of a sector. Because this is a minor arc, we call this part minor sector. So this is our minor sector. Students should actually do this activity themselves. That's why they have to bring paper cutouts on white sheets to perform the activity in the classroom. So this is our minor sector, and the major sector is the area between the major arc and the two radii joining the center with the endpoints of the major arc. We can easily note that the endpoints of minor arc and major arc coincide with each other. Sectors are the areas between two radii and an arc. We can consider diameter as also a combination of two radii, OA and OB, that joins the endpoints A and B and forms two arcs. One is AB on this side, another is BA on that side. These two are also sectors but of equal size. Having described segment and sectors, lastly we shall tell about two more lines. One is a secant. It is a line that intersects the circle at 2 points on the circumference. This is a secant. And another line is tangent. Tangent is a line that touches the surface of the circle at only one point. Just at this point, it touches and passes through. It never enters the interior of the circle. This is a tangent, and this one is a secant. That is all about circles and its parts.